Morning, sir.
Well, as I mentioned, before we start this session, a small message I would like to give to everybody. Probably it will generate some more interest in this session. Let's quickly go through that part. What is the objective of this session? And then we'll stop for 5 minutes to understand it. And then we will start the real session. Okay. As we always mention that our role is a role of a mentor to prepare students industry ready. So this is the 7th session. As I mentioned, there is a message. Before we start the session, I would like to cascade this message to everybody. Let's look at this. There are 4 industrial revolutions has taken place. Back in 17th century, end of 17th century, when that was the first time when motors started coming. That was the time when that was the pre-industry period. So when the first time there were some activity where machines started converting to human advantage. The machines were used to roll the wheels. That was the time when the concept of automobile started. In 1870, again, end of 19th century, the mass production started. Industries started building up. Large industries started building up. That was the time when, there was a movement across the world. Paper mill started, steel plants started. Whichever raw materials were there, minerals were there, mineral related or raw material related, which is freely available in nature. Depending on those things, the lot of industries started and jute mills started coming up. So that was late 1900. There was a big change that time. Sometime end of 20th century, computers became popular. Desktops started coming on tables. Electronics, there were a lot of improvements were there. Automation started coming in industry. Many of the industries work which was done by man, it was slowly given back to the machine, especially in automobile industry. Many of the jobs were like assembly section were done by machines. So the robot started, the concept of robot started coming after the computer started becoming very common to the human being. That was 1970. There were, many industries where these are all much earlier than you were born. So that was the time when in 1980s, 1990s, a lot of protests were there across India. People were panicked that if machines started doing the job, the human will lose their work and their employment. And there were a lot of resistance were there. But eventually, everybody accepted. Computer became now so powerful. Even in mobile, you have got so much of computational power. That was 1970, 1980s. This is the time, 2020, 2021. It started from about 5 years ago. There is a new concept started emerging. They started combining three things. One is computer, one is human, and artificial intelligence. Now, artificial intelligence, machine learning became a in thing. The whole industry which will be seen in future will be completely different than what it is today. And you guys are right at that threshold. You are there during the time of this change. When you will be 50 years old and when you look back at what was done in 2020, 2030, in between this period, there will be huge change will be there. It will be something similar to what happened in 1970, 1980. So you are in the same wave. 1970, 1980, there was a panic. Same thing will be happening 2020 to 2030. A lot of change will be there. The whole concept of industry will change. And that is where it is so important that the modern engineering students should understand that what is that concept? What is that future industrial revolution you are going to face? And that is where our role is to prepare yourself for that. We are not only working for students, we are also working for industries also. We are making industry ready for fourth revolution, industry 4.0 we call it. Every year, there is a meeting held, typically in Geneva, Switzerland. It is called World Economic Forum. Incidentally, in 2020, the World Economic Forum has completed 50 years. And this is the forum where all leaders, presidents, prime ministers, all industry CEOs attend. UNO people attend. It's all leaders across the world attend it. World Economic Forum. You can Google search it. Last year was 50th year. Now, this is where the policies are written. How the world will change over next 10 years. These are the concepts are being taught. In 2020, last year, in that economic forum, this was a statement given. Industry 4.0 revolution is included as strategic intelligence in the solution to rebuild the economy following the COVID. Now, you know that we all are under a tremendous economic pressure because of this pandemic, because of this COVID. All countries across the world is under pressure, economic pressure. Jobs are going, economy is going down, profits are going down. Now, this is the time, what should be done? So this was the topic during last session. It was held in month of April or May 2020. And it was recognized that Industry 4.0 is a solution which is which will give a direction which will help to improve the economy. This is where we are. You are young engineers. You are the future. You are the backbone of any future, any change in the future. We are from industry. We have taken a very small initiative in developing the third year and final year student, engineering undergrad students, to be Industry 4.0 ready. So this is the purpose. So look at the purpose. We are not doing in a conventional way. Right now we are in industry 3.0. India is right now here, industry 3.0. Now we all know that we are going to move to industry 4.0. How do we know? So the statement what I'm making is supported at the World Economic Forum. This is the largest forum where world economy is being discussed. And that is where they mentioned that industry 4.0 is the solution. Now, if we know that to go from 3 to 4, we have to learn it. We have to learn what is the difference here. That is where we are coming into picture. That is where we are making you ready to understand what is this industry 4.0. How do we do it? So this is the way we are doing it. Now, this is our last slide before we take a small break. Now, what we are doing, that we are applying your theoretical knowledge in doing practical industrial problem solving. And then, after you understand the basics, how do you apply this, your theoretical knowledge in solving industrial problem? Then comes building mathematical model or rule engines. Now, whatever you learn from our discussion, that okay, this is the way theoretical knowledge is converted into practical application. Fine. Then what? Then we make mathematical models. You will be making. Students will be making these mathematical models. Then the model what you have prepared, we will use it in the AI logics, artificial intelligence logic. This is industry 4.0 I'm talking. This is where the future will be. Now these models, what you will be preparing, we will be using it in the logic, the machine learning logics. And then we will see that using your models, your mathematical models in these logics, how do we help decision making? How do we solve problems? And this is how it will be done in future. The future industry, as I'm repeatedly saying, is a migration from the present concept to a different concept, a new concept, where machine learning will play a very big role. Now, as a mechanical engineer, where do we fit? Our role is we must understand the theoretical knowledge, converting the theoretical knowledge you have acquired, you are undergoing right now in your engineering studies, to practical application. Once you have done, then you build mathematical models. And then use these mathematical models in the logic solvers. And these logics are used in doing decisions, in making decisions, in instructing the machines to perform. The instruction goes through these models. So it is, we are not only learning the industrial application, we are making ourselves ready for the next revolution. We are getting ready for industry 4.0. Imagine 10 years down the line, you guys will be about 30 years old. And that is your peak of your career, professional career. And that is the time you should be ready here. This should be booming business, industry 4.0. In year 2030 onwards, it will be booming business. And if you are ready, you see your value in the market. You will be contributing to the benefit of the industry, to the nation. Well, that is a very short message I want to give that this learning, these sessions, whatever we are talking, is a foundation to prepare yourself for a new industrial revolution, which you will be at your peak of your career, you will be part of it. Thanks. I break for a while, have a feel of it, and then I will go with the normal normal stuff on centrifugal pump. So I'll break for a couple of minutes and then we'll restart. Over to you, Raju. ये जो what we are going to learn over next few sessions by mechanical only. So we have on hydraulics, we have done certain clarification on the hydraulics. We applied on centrifugal pump. So these are the things we had gone through of centrifugal pump, the affinity laws. We focused on centrifugal pump. We talked about the graphical representation of its performance. Now let us look at it, where we are. We are on 7th session. And today I'm just giving some idea about the concept. Starting from next session, we'll start making the mathematical model. And then how it will be developed in the next sessions. The 9th and 10th session, these are very, very tentative. The mathematical model of centrifugal pump will hopefully will be ready. This will be done by you guys. And the one who had done the best, we will take that and move forward. Then what we will do is that we will introduce you to another machine, little complicated machine, screw compression. Centrifugal pump, so far we were doing, we will switch over from centrifugal pump to screw compression. So we want to expose you to somewhat complicated machine. And then we'll show you that how this model can be applied for this machine as well. So then we will develop this model for screw compression. Then we will use this model and then introduce to the software of screw compression. So in this next 2 sessions, we will apply your model of screw compression to the software. Then in these sessions, you will start doing hands-on on the software. You will start working on the software and try and do experiment to understand what is the role, what is the meaning of this mathematical model, what is the meaning of all these theoretical things, why it is so important. So you will have a feel of it. You will start working on it. We will give you access and then you will work on it. And then depending on the model you have ready, decisions will be generated. The results will be generated with the software. So how important is making a right mathematical model to get a right decision. If your model is wrong, then decision is wrong. So you will have a feel of it that how decisions are being taken at the plant level. And then we'll close out the sessions. So right now we are on 6th session, 7th session. So we are looking at ahead almost 10, 12 sessions more. And since it is a session where a lot of hands-on will be there on the software, hopefully you will enjoy it. Okay, so this is an industry where centrifugal pump is being used. We discussed all these internal components. These are the fluid dynamics you have done. And these are the curves we discussed that day, last session. We took up 2 cases. where the suction is at the center line of this, and then these are the curves, and then another is where the suction is below the center line, and this is another curve. So we explained what is the best efficiency point, and this is where we left last time. We talked briefly about affinity law. So these are the different diameter of the impeller. So how this, because of the affinity law, how you do the calculation. There was a video also there. Did you go through this video? Students, did you go through this video?
Students, you can open your mic and talk. Sir, this audio is not there. Cannot hear. DD sir?
Yes. Yes, please.
Sir, this audio is not there. We cannot hear any audio. Is there any audio? It just
Oh, there is no audio.
we cannot hear the audio. Students, can you hear the audio?
No, sir.
Yeah, so please tell if you don't hear. Yeah, I think, sir, this audio will be not. So it's better that the students should go through this individually.
Okay, fine. So, students, you are requested to go through this video. It's a very informative video. It is produced by one company called Kirloskar. It's an Indian company. And this centrifugal pump is used very commonly in India and across the world. It's a very informative video, and it gives you basic concepts of the centrifugal pump. So I leave it here. So I just wanted to demonstrate that there is a video there. Please go through it. It will give you some better concept. So I'll move on from here. Now guys, last time I had given a task that have you understood it? Have you understood? Because it is important that if you don't understand, there is no point in me going for more complex calculations, developing mathematical model. Now you need to stop me and ask me that I don't understand this part. Students, I need some response from you guys.
सर आप एक बार फिर से वो एक्सप्लेन करेंगे क्या?
Yeah, sure. Well, मैं एक बार फिर से explain कर रहा हूँ. I'm explaining it one more time. I'll explain you as many times as you mention. But then at least once you have to explain it back to me. Then only I will go to the next sessions. I'll just give you a feel of next part of it. Then I'll come back here. मैं आपने जो पूछा है मैं आ रहा हूँ इस पे फिर से बताने के लिए. But then we have to start working on this thing, that the calculation, the power calculation, efficiency calculation. Now these are the curves. We have to understand it. What is these curves? Now for understanding this stage, and then only we will go to the developing the mathematical model. It is important that we understand this curve again. Now to understand this thing, let us go back to our this drawing. This is the pump. Now this pump is taking suction from this vessel. The liquid level is here. So it is taking suction from here. And this is the discharge. And it is delivering to this vessel. Right? Now we want to understand what is happening. What is that fluid dynamics, fluid mechanics you have studied, how it applies here. First we learned that. The theory you have studied in your engineering, how it is applied in this case. Once we understand, then we see that how this knowledge is useful for industry application. Industry application में क्या होता है कि जब इसमें problems आते हैं, then we try to find out why this problem has come. Now for understanding that problem, your theory must be clear. Then only you will understand the problem. For understanding the problem, we will use the graphs, these graphs. Once we have understood the problem, then we know how to solve it. Now for solving this, we start making mathematical models. तो हमने जो theory सीखा है उसी के base पे we make some models. And these models are fed into the software. And the software will run, and then it will tell that if this problem is there, it means this is the reason. The software will tell that the way the pump is behaving, most likely within next 7 days, there could be some issue. Now, software तो खुद बताएगा नहीं कुछ. Software के लिए logic चाहिए. Logic कौन build करेगा? Mechanical engineer build करेगा. Now, mechanical engineer किस basis पे build करेगा logic? उसके लिए उसको ट्रबल शूटिंग मालूम होना चाहिए, उसको ये ग्राफिकल रीडिंग उनको क्लियर होना चाहिए, तभी वो लॉजिक बनाएगा. और उस रीडिंग को क्लियर होने के लिए उनका जो फ्लूइड मैकेनिक्स का जो थ्योरी है वो क्लियर होना चाहिए. सी द रिलेशनशिप. Clear? Okay. Now here. So this is what we talked about. That this suppose this is a water pump. So this is a water. This water level is much higher than the central line of this pump. This is a pump central line. So this is the height. The water is always available. So it takes this water from here and then delivers it to here. This is the vessel where it has to deliver. Now, there are some terms are there. And this is called static head. From this level of water to this level of water, it has to pump. In the line, there are several losses are there. We will be discussing this thing while preparing the mathematical model. These losses. Each line has got frictional losses. There is a valve losses, inside losses, again valve losses, in the pipe losses. So these are called frictional losses. These frictional losses also you have studied in your class. So it has to work. This pump must work to overcome this much load plus the frictional load. So total load is 20 plus 8.6, 28.6. Now, suppose this vessel is not here. The vessel is below the central line. Then additional load is coming कि यहाँ से उसको central line तक water को pull करना पड़ेगा. So the additional load is there. So there is an additional load is coming, suction head. Static head is there. Then friction loss is there, common for both. And then suction head is there. So here total loss is more. Total load is more on this pump. So in this case, the load on the pump is less. In this case, load on the pump is more. Clear?
Yes, sir.
Okay. Now let us look at how it is represented by graph. Graphically, how it is represented. Graph is your language. Engineer's language is drawing and graph. Now, this is your language. This is what you are speaking. We mechanical engineers speak less and talk about these graphs more. So we need to understand this graph. So let us try to understand. The first graph is called head. And here it is flow. The bottom line is flow. This is liter per minute. This x-axis is flow, liter per minute. And y-axis is head. There are more graphs are there. Hour graph in kilowatt, NPSH graph in meter, and efficiency graph in percentage. Will come later. So पहले हम देखते हैं head graph and flow graph. तो head graph और flow graph में आपने you can see this curve. This is the behavior of this impeller. Each impeller has got a unique behavior. Impeller, centrifugal pump का heart. Impeller converts your converts the work done. Work done is done by the motor, and converts that work done by the motor into energy, and pulls the water from a lower level to a higher level. Now, what does it mean? What this graph means? So, in this case, we see here that this pump has to work for 28.6 meter. It has to minimum generate 28.6 meter. Whatever this motor is giving power, the power should be enough to pull this water from here and deliver it at 28.6 meter height. So this is the purpose of this pump. 28.6 meter height it has to pump from this level to this level. Correct? So this is 28.6 meter. This is 28.6 meter. So 28.6 meter, we do in the workshop or in the manufacturer's workshop, the characteristic of the impeller, ये जो impeller का behavior है, उसको हम लोग test करते हैं. Test is being done. So at different height, how much this impeller is pumping, we see how much flow it is giving. So in this case, at 28.6 meter, it is giving 1820 liter per minute flow, for example. So इस case में, this pump is generating, this impeller is generating at 28.6 meter, this is called head. इतना head इसको generate करने का. The water has to be pushed to 28.6 meter height. For this height, it will give 1820 liter per minute flow. Now you see, if you want that it should give much more height. Suppose you push this vessel little up. Then say this head has become 20, has become 22. Now this is 20 meter height. Now you push it 2 meter further up. It has become 22. Now friction head is 8.6. So it becomes 30.6. So if it is 30.6, this is 28.2. Suppose it is 30, somewhere here. So maybe it is 1700 liter per minute. Now suppose you want not 30, you want total to be 35, for example. You increase it further. This vessel you want, you push it further up. And total becomes 35 meter, for example. 35 meter, 32, 33, 34, 35. 35 is somewhere here. So it will give only 1400 liter per minute. So what you are seeing, that the more you push it upwards, the flow from this impeller will start going down. Similarly, if you push this vessel downwards, suppose this 20 meter, I am reducing it by 2 meter, 18 meter. So this becomes 28.6, becomes 26.6. So 26.6. So it will give more than 2000 liter per minute. This is concept of head. How much head it has to generate, how much pressure it has to build. Pressure and head are same thing, only units are different. As you can see, जैसे जैसे flow कम होएगा, pressure बढ़ेगा. आपका flow का requirement कम होएगा, pressure will increase or head will increase. If you increase the flow, the pressure will reduce. Now this is called head flow curve or pressure flow curve. So this impeller follows this nature of this curve. This is experimented. This is tested at the manufacturer's workshop. वो test करने के बाद, they give this graph, and they give this graph, and they provide this graph to the user. For example, the pump which is there in your housing complex will also have some kind of curve, head flow curve. And when you measure, अगर उसमें flow meter लगा हुआ है, if you measure the flow here, you will see the discharge pressure is equivalent to 28.6 meter. How do we calculate discharge pressure? We'll talk later. Now this part is clear. Is it clear that what is the meaning of head and what is the flow relationship? Is it clear? Should I move
Yes,
further?
sir.
Yeah.
हाँ सर.
ओके. नाउ नेक्स्ट है कि ये जो वेसल है इसको हम नीचे लेके जाते हैं. तो नीचे ले जाने से क्या होगा? वी आर इंक्रीजिंग द हेड. अभी 2.4 मीटर और बढ़ गया. नीचे पानी को नीचे से भी पुल करना होगा. सो से टोटल हेड इज 35 मीटर. So 35 meter. So 35 meter is here. And so it is giving about 1400. It is 36 meter per draw kiya hai. मान लो कि 35 meter will be slightly less. So maybe 1450 liter per minute flow there. So you see here, in this case, हमने सक्शन का जो वेसल है, ये सक्शन का वेसल को हमने नीचे कर दिया. डिस्चार्ज को हमने कुछ नहीं किया. सक्शन के वेसल को नीचे कर दिया. तो हमारा जो रिक्वायरमेंट है बढ़ गया. Our requirement has gone up to 35 meter. So 35 meter corresponds to less flow. क्योंकि हमें ज्यादा काम करने का है पंप को, इसलिए the flow it will deliver less. If you lower that suction vessel further down or you increase the discharge vessel further up, the flow will start slowly going down. Now if you see, this impeller can give only maximum head up to 41 around. आप अगर इसको और भी नीचे करते हो, ये 35 मीटर है, इसको नीचे करते हो, so it becomes 41. What will happen? Students, मान लो कि इसको और भी नीचे करते हो, and this total becomes 41. So in this curve, if you see it, what will happen? कितना flow आएगा?
सर 8,000 to 800 to 1,200 के बीच में आ जाएगा.
नहीं सही नहीं है. यहाँ पे हमने इसको नीचे कर दिया. ये जो वेसल है, सक्शन का जो पानी है, उसको और भी नीचे कर दिया और टोटल हो गया 41 से. अगर 41 हो गया तो 41 किधर है? यहाँ पे देखो, यहाँ पे 32 है, 36 है, 40 है, 41 है. 41 is almost here. तो आपने क्या बोला? रफली 800 to 400 के बीच में आएगा.
1,200 सर.
हाँ, तो आप यहाँ से ये 41 पे एक लाइन ड्रॉ करना, and then where it intersects, that is the flow it will be. मान लो कि 41 से ये 42 पे चले गए, तब क्या होगा? Suppose you lower down this water level and total has become 42. Then what will happen? तो हमारा रिक्वायरमेंट अभी 42 हो गया. 42 किधर है? ये 40 है, ये 44 है, ये 42 इधर है. ये लाइन के ऊपर में है. ये जो लाइन है, ये कर्व है, उसके ऊपर में है. इसका क्या मतलब हुआ?
सर वो पंप वर्क नहीं करेगा.
बिल्कुल पंप वर्क नहीं करेगा. पंप विल नॉट डू एनी फ्लो. कुछ भी पंप नहीं करेगा. Is it clear to other students?
Yes, sir.
Yes, sir.
कौन बोल रहे हो?
कार्तिक सर।
अच्छा कार्तिक, ये बताओ, मान लो कि ये फ्लो दे रहा है 1600 लीटर पर मिनट, तो कितना हेड आएगा? 1600 यहाँ पे, तो कितना हेड डेवलप करेगा ये? तो 1600 से आप ऊपर जाओगे, you will see where it cuts this line curve, फिर you go towards the left, suppose it cuts at 32.
32.
So what does it mean? It means if the total head is 32 meter, it will give 1600 liter per minute flow. बराबर?
Yes sir.
क्लियर है ना? इतना तो क्लियर है?
Yes sir.
Yes, sir.
Who else? Anybody जिसको समझ में नहीं आया? हाँ तो बोलो. Other students? Hello? Okay, so we go to the next curve. It's called power curve. Power is calculated like this. Is the flow, जैसे हम लोग बोल रहे थे ना 1400. Then the density of the liquid. Water का क्या density होता है? हाँ? Karthik, what is the density of water? What is the specific gravity of water?
One.
Specific gravity of water is 1, correct? G, you know, कितना होता है G?
9.81.
Correct. H head, the same thing but we just noticed. This is the head, 28 meter वगैरह, and efficiency of the pump. So this is the power curve, power equation. Power equation is the multiplication of capacity, density, G and head, and divided by efficiency. So in this case, this is your head, this is your flow Q. Rho मालूम है, पानी अगर है तो 1, और so you calculate the power. Now the efficiency is coming from here. Say 61.1% is the efficiency. Power is coming 11.9 kilowatt, and 28.6 meter is the head, and flow is 1820 liter per minute. So during next session, you guys, can you calculate कि अगर head दिया हुआ है 28.6 meter, flow दिया हुआ है 1820 liter per minute, efficiency has 61.1%, then as per your calculation, are you getting this value or not? 11.9 kilowatt. Do this calculation next session and see whether you are reaching to this value or not.
Okay, sir.
You will use density for water. You have been given Q, you have been given H. From the graph, you get the efficiency, and then calculate power. See whether it is matching with the value over there or not. Okay, so this is power graph. This is efficiency graph. And there is another term called NPSH. When you see that video I was showing you, the Kirloskar video, you will get a feel of NPSH. NPSH का मतलब होता है कि there is a term called cavitation. Cavitation is a concept. Cavitation is a concept which is we'll cover in next session. What is NPSH? It is important for the functioning of the pump. So do this calculation, simple calculation. You can try out different location. You can consider, for example, here, say the efficiency here is 65.9%, head is 36 meter, flow is 1400, and then calculate what is the power. Is it matching? आपका power calculation यहाँ के साथ match हो रहा है नहीं हो रहा है? तो उसमें क्या होगा ना, when you make error, then you will learn also कि अच्छा क्यों error हो रहा है. Okay. Now एक चीज और पिछली बार हमने बताया था कि ये efficiency का कर्व देखते हो, efficiency curve. This is where it is maximum. And इसके पहले भी कम है, इसके बाद में भी कम है. So this is the place where the efficiency is maximum. इसको कहते हैं best efficiency और इसको कहते हैं best efficiency point, BEP. So this is BEP, best efficiency. 65.9 is the best efficiency. So किसी भी कर्व में, HQ कर्व में, head flow कर्व में एक best efficiency point होता है. और in this curve, this is the best efficiency point. तो जो भी डिजाइन होता है, when we design it, और जब हम उस पंप को फील्ड में यूज करते हैं, तो we try to use in such a manner that बेस्ट एफिशिएंसी के आजू बाजू में ही ऑपरेट हो. जैसे इसका बेस्ट एफिशिएंसी है 1400 फ्लो पे और 36 मीटर हेड पे. यहाँ पे देखो ये 35 मीटर हेड पे चल रहा है, 35 मीटर हेड पे चल रहा है, और यहाँ पे बेस्ट एफिशिएंसी है 36 मीटर, मतलब वेरी क्लोज. ये बेस्ट ये जो पंप ऑपरेट हो रहा है, ये वेरी क्लोज टू बेस्ट एफिशिएंसी ऑपरेट हो रहा है. This is very good condition. This is very good thing. The machine should operate near best efficiency point. लेकिन पिछली बार जो था, पहला वाला जो था, it is operating at 28.6 meter head. 28.6 meter head. 28.6 meter head is here. Best efficiency is here. यहाँ पे efficiency 65.9 से drop होकर 61.1 हो गया है. So this is not the good way to run this pump. इसका मतलब है कि ये जो रन कर रहा है, this is not good. So as an engineer, you will be telling, आप सही नहीं रन कर रहे हो. You are running at far away from best efficiency. This is good. You are running very close. क्या होता है? So in this 28.6 जो कर रहा था, they were running somewhere here. ये 28.6 है. देखो यहाँ पे ये बेस्ट एफिशिएंसी है और रन हो रहा है यहाँ पे वो चला रहे हैं, मतलब इसके राइट साइड में चला रहे हैं. मतलब बेस्ट एफिशिएंसी अगर यहाँ है, दे आर रनिंग हियर, तो इसका बियरिंग बहुत जल्दी खराब हो जाएगा. जो दूसरा केस है, जो बिल्कुल नजदीक में चला रहा है, that is the best. This pump will run very healthy for long period. So देख रहे हो what happens that ये पंप ज्यादा काम कर रहा है, 35 मीटर हेड जनरेट कर रहा है, और ये पंप कम काम कर रहा है, 28.6. कम काम करते हुए भी ये जल्दी खराब हो जाएगा, ये ज्यादा काम करते हुए भी जल्दी खराब नहीं होगा, क्योंकि it is operating near best efficiency point. So it is not that if something is running at a higher load, it means it will have more failures. No. So it all depends on where you operate. बराबर, जैसे हमने एक एग्जांपल दिखाया था वो फोटोग्राफ में, ये जो इम्पेलर का कंडीशन ऐसा है, मोस्ट लाइकली मालूम है क्या हो रहा होगा, ये जो जिस प्लांट में ऑपरेट हो रहा था, they might be operating somewhere here. Either they are running here, low flow cavitation, or they are running here, very low head or very high head. Either यहाँ रन कर रहे थे या यहाँ रन कर रहे थे. And this cavitation is, we will cover next time, is something to do with NPSH. So we will talk later. जब ये समझ में आ जाएगा, then we will talk. So students, do you understand the importance of this BEP? Or should I repeat? आपको समझ में आया?
Yes, sir. Understand, sir.
See, I was trying to make you understand that it is important as an engineer to know what is the limit of a machine. If you are running it there, you are fine. If you are running less than that, is also a problem. If you are running more than that, that also a problem. So it is important to recognize. उसको समझना बहुत जरूरी है. तो आप एक्सपेरिमेंट करो डिफरेंट कंडीशंस पे, ये फॉर्मूला डाल के देखो आपका फिगर कर्व का फिगर मैच कर रहा है या नहीं. Right? There is one more thing. This is the last thing. I will end here. This is a same curve, but these curve are, see here written 184, 165, 150, and this line is for diameter. So this diameter is 184, diameter is 165, diameter is 150. This is the diameter of the impeller. This is the impeller. This impeller has a diameter. जैसे यहाँ से लेकर के यहाँ तक, this is diameter. This is called diameter. Now, if you cut it, you can make it smaller impeller. The diameter will become smaller. So usually, जब impeller cell होता है, so it is slightly bigger. And then depending on your requirement, you cut it to appropriate size. जो जरूरत होता है उसी size पे आप run करते हो. तो कैसे decision होता है cut करने का? कट करने का डिसीजन होता है affinity laws. This is also one of the thing in hydraulics you have studied. Now, when you say D1 is the original diameter, D2 is the new diameter. So if you change the diameter, the flow will change. Head will change, power will change. this is speed. Since you are not changing the speed, so N2 and N1 is equal. So only Q is changing proportional to diameter. Flow is changing proportional to diameter. छोटा कर दोगे तो flow छोटा कम हो जाएगा. Head is in square of diameter. तो diameter जितना change करोगे उसका square way में head change होगा. और power Q पे change होगा. Now, these are the three curves at three different diameters. 184, 165, 150. Now, accordingly, everything is changing. Power is changing. You can experiment. मान लो कि ये 184 पे यहाँ पे आपने 45 मीटर पे या देख लो कहाँ पे है ये आपने कितना फ्लो है अभी इसको आप काट करके 184 को 165 करो and then you apply this formula Q2 185 164 करो 184 to 165 184 divided by 165 Q1 at 184 is say meter cube per hour is 60 meter cube per hour. तो जब ऐसे ही कम किए तो how much it will reduce? Calculate it and see on this graph. It is matching or not. Students, ये simple सा task है. Do it because you will start enjoying when you go to the software side of it. So you will be making, a lot of things over there, and you will be experiment. आप खुद करोगे ना सॉफ्टवेयर में जब अंदर में जाओगे, and ये जो formula वगैरह जो है, these formula you will be using. These are the mathematical models. ये formula आप use करोगे, and then you will put into the software, and then you will see what is happening, how this graph is changing, how the decisions are being taken. जैसे मैंने बोला ना यहाँ पे कि the decision is taken that don't operate this pump at lower head. आप operate इस पे करो. आपका failure हो रहा है इसका मतलब आपका problem यहाँ पे. तो ये जो decisions हैं, these decisions depend on these equations. इसकी understanding है, graph का understanding पे depend करता है. This affinity law you are using it. Okay. Now, read this curve. This curve is the same way that other one. This is that head curve. This is the efficiency curve. This is a power curve. And this is the NPSH curve. We have not discussed it. We'll discuss later. Same thing we are talking. ये जो blue lines हैं, these are the area where efficiency is maximum. This is the high efficiency zone. So preferably you should operate in this line, somewhere here, in this zone. So this is called operating region, preferred operating region. This is the location where maximum efficiency is there. So this is the interpretation of same thing what we talked in a different is all put together. This formula you can use it. There are certain more graphical formations are there, but since you are not clear, so अभी मत करो ये जो दो ग्राफ मैंने दिया है, don't do now. We will understand it next time. Try this, experiment it, करके देखो आपका रीडिंग, आपका वैल्यू और ग्राफ का वैल्यू मैच कर रहा है या नहीं. ये जो वीडियो है, run it and see. Apply this formula at different impeller diameter, and see whether it is matching or not. concept of DP is important. ज़्यादा run करोगे तब भी problem है, कम करोगे तब भी problem है. Is it a little more clear, dear?
Yes, sir.
Try yourself, because once we go to the next stage of modeling, we'll be using the same formula, but we'll be using the formula for some specific purpose, and then you will start having a feel of it कि अच्छा जो सॉफ्टवेयर वगैरह जो बनता है ऐसे ही बनता है. This is the way it is being made, and then you try it out, and the same concept हम एक दूसरे मशीन पे ट्राई करेंगे, स्क्रू कंप्रेसर पे, जो मोर कॉम्प्लिकेटेड मशीन है. So उसमें we will be introducing few more things. Thermodynamics also we will be using it. So before going to that level, this is a very basic thing, very basic, simple thing. You need to understand what is the meaning of this graph. Once you are comfortable, then next session onwards, we will move towards little complex. Okay? That's all from my side. You need to ask questions.
Please ask questions if anybody has anything.